Hey guys, so as I promised in the previous video, we will be doing K-maps in this session, and I will be going in depth into K-maps because a lot of people make a lot of simple mistakes which can cost you a lot of marks in the examination, right? So when we talk about K-maps, these are the K-maps that we have in our syllabus, right? We have this for two variable for K-maps with two variables, this one for K-maps with three variables, this one for K-maps with four variables, right? So when we talk about K-maps, the first thing that we have to realize is that each square in a K-map represents one square of the truth table itself, right? So for example, if we take the two variable truth table, there are four squares, right, for outputs, and for each of these squares we have a square in the K-map, right? So since there's four squares in the truth table for two variables, there will be four squares in the K-map for two variables, so on and so forth. It's the same logic for the other two that we will be using, right? Okay, now we'll talk about how the numbers around the K-map actually decide the value of the numeric value that is given to each of the squares, right? So even though this is the usual pattern that you see for these numbers to actually be situated around the K-map, that doesn't mean that that's the only way that it can actually be, right? So in some A-level questions we get, they give us 5 K-maps for the MCQs. They give us 5 MCQs, 5 K-maps for the 5 answers of the MCQ, and then when they are giving that, they actually switch these numbers, right? In each answer, the numbers are all switched around, right? And they're asking for the correct one or the incorrect one, right? See, there are many patterns where these numbers can exist, but there is a certain logic to it. So if you understand the logic of actually placing these numbers in the pattern, then you can actually figure out which is right and which is wrong, right? So this is how you actually figure out whether it's right or wrong, right? So these numbers these numbers, you take them and then you write them down vertically like this, right? You take them and write them down like that. All right, so after you write them down, even these you can write down like this, right? Yeah, so after you write them down, you take a closer look at it, and then what you have to do is see if this one condition is met, right? So the condition is, if the K-map is correct, the numbers should all be able to be coupled together, right? So for example, this is the pattern that's most commonly used. So if this is correct, then this 0 should be able to be coupled with this, right? So this 1 can be coupled with this one can be coupled with this, and this 0 can be coupled with this 0, right? So like that, the numbers should be in a position where you can couple them with the one, with at least with one similar number that is situated right above or below the said number, right? So again, this 0 can be coupled with this 0, right? So this one can be coupled with this one can be coupled with this, and this 0 can be coupled with this. So like that, the numbers should be in a position where they can be coupled, right? So if by any chance you see a K-map with the the numbers positioned in a way like this, right? We just mix it up and see whether it works or not, right? So we'll keep it like that and see whether you can couple them, right? So see over here we can couple this with this, right? And we can couple this 0 with this 0, right? But these cannot be coupled because they are not right above or right below them, right? So if you see this pattern in a K-map, then that K-map is actually wrong. So this is how you figure out whether the numbers around a K-map are correct or wrong. And according to those numbers, the numeric value will be given to each and every square inside the K-map. Alright, so with respect to the way that I said that these numbers are placed, the patterns that these numbers are placed, now we're going to talk about what these values are made out of, right? So when it comes to the truth tables, you all know that in every truth table, the value that there's a value for every row, right? So for the output of the first row, it's always the value is 0. For the second row is 1, the third row is 2, so on and so forth. And it's created by using these numbers, these zeros and ones as a binary notation, right? So for example, since this row, if we take this row, the binary notation would be 0 1 0 0, right? So 0 1 0 0 initially means 4. So the output value, the output binary value that should actually come here is 4, right? So because I said that every square in the K-map represents a square of the truth table, square of the output column of the truth table, just in the K-map as well, we have values that are corresponding to the actual values that are on the truth table, right? So for example, the fourth row of the truth table, the fourth row of the truth table with 4 variables is 3. The value is 3. The numeric value is 3, right? So in the K-map, the corresponding K-map, which is the 4 variable K-map, there is a square with the value 3, right? So if you see something written here, that means the same thing should be written in the truth table in the corresponding line, which is the fourth line's output square, right? So just like that, the values are found out and the values are actually related between the K-map and the truth table. And just like the 4 variable one, in the 3 variable one, and in the 2 variable one, each square has a value which you can see written in red. Alright, now we are going to talk about how these letter notations and these numbers actually connect with each other, right? So every number is representing the corresponding letter, right? What that means is, since these two letters are on this side of this K-map, right? These two letters are represented in this column by these two numbers. In this column, they are represented by these two numbers. In this column, by these two, by this. In this column, they are represented by these two, right? So, for example, if you wanted to see, let's say, take A, right? So A, in this column, A is 0, right? In this column, A is 0. In this column, A is 1, and in this, A is 1, right? So just like that, B is represented by these digits on the right hand side, and just like that happened in this area, the same thing is happening in this area with C and D, right? So for example, C is represented by these numbers on the corresponding rows, and just like that, D is represented by these numbers in the corresponding rows, right? Alright guys, so what we are going to do now that we've already completed the introduction part is that we're going to be marking K-maps, right? So just like I said before, in every K-map there's a lot of squares, and each square is corresponded to a square or an output in the truth table, right? So we're going to start off by marking the truth table and the K-map with two variables, right? Because that's the most simple one. So yeah, so first off, we're going to be doing this in a really simple way, and when we are moving forward, we'll be skipping small steps, right? So when you're marking, the first thing you have to do is you have to select you have to find out the squares in which the number 1 is there in the truth table, right? So the number 1 is there only in two squares, only in two output situations, right? So after you find out the ones, what you're going to do is you're going to there's two methods that you can use. You can either use the binary values to actually find out where the squares are, or you can use the numeric values, right? So for the first one we will be using the binary value, for the second one we will be using the numeric value, right? So when we are going to mark this one, so it's the 0 is there for A and 0 is there for B, right? So we are going to go to the K-map and look for the place where the A side is 0, right? So that's this column. I'll make it more clear for you. So A being 0, that is this column, right? And B being 0, that is this column, right? So the only place where those two conditions are met is this square, right? So because of that reason, we will be marking this square as a 1, right? So after we do that, the thing that we have to do is we have to mark all the other ones, right? So as I said before, the next one we will be using the numeric value for, right? So for this one, the numeric value of that column, of that row is 1, right? It's this 1 is situated on the second row, and the numeric value of the second row is 1, right? So we'll go to the K-map and we will look for the square with the numeric value 1, which is this square right here. So we'll be marking that as 1, and there we have the most simple way to mark a K-map for the sum of products method, which we will be getting to in a little while, right? So first off, when we are marking these things, we'll be marking the K-maps for both sum of product and product of sum, so that we can use it later on right off the bat, right? So because the other things are 0 in this, we will be marking the others as 0, right? So there we have it. There we have a completely marked K-map corresponding to this truth table. Alright, now that we've completed the 2 variable K-map, we're going to be doing the 3 variable K-map. And we're going to be using this truth table with the 3 variables, and I just marked it in 2 colors, blue and orange, so that we can separate it and mark it in the 2 methods that I taught before, so that it can be even more clear for you all to actually do it by yourselves, right? So the blue part we will be marking using the binary notations, the binary values that are stated over here, and the other part, the orange part, we will be marking using the numeric values that are stated over here. So we can see that the whole blue part is having 1 as the output, right? So we will be quickly noting these numbers down, and then we'll go to the K-map. So the four numbers that we have to, the four squares that we have to get 1 marked in are the squares that have 0 on the A column, right? Every output with A as 0, right? Every output with A as 0 is 1, right? So we're going to go here and we're going to straight away select every output that has A as 0. We're not going to be thinking about the rest, because it's very clear that the rest actually don't matter, because it's very apparent, right? So we're going to use the A notation only, and we can see that this column, right, this column and this column have A as A0, right? So we will be marking all those squares with 1 because of that reason and that reason only. So these will all be getting 1 on the K map, right? So now we're going to move back to the truth table, and now we will be looking at the orange parts, right? So when it comes to the orange parts, we can see that there's only one digit, one output with 1 as the value, right? So we only going to be considering that one when we are marking the ones. So the binary value will not consider right now. We'll just use this, the numeric value of the corresponding row, right? So the row, the output with the numeric value 4 should be A1. So as you can see here, we have the our K-map square with the numeric value 4, so we will be marking that one as A1. And as you saw in the truth table, every other square should be 0, so we'll be marking those as well. So now we have a completely marked K-map that is corresponding to this truth table with 3 variables. Okay, so now we will be moving on to the truth table and the K-map with 4 inputs, right? So in this one, I'll be very clearly showing you how to mark the first few ones, okay? So after that, I won't be going in depth into it because we have limited time and we have a lot to do, right? So apologies. We will be marking the first line right now. So the first line is a 1 and it has zeros for all the variables, right? So we're going to find the square with all the variables as 0, and that will be a 1, right? The second line is the second line has 0 0 0 1, and we're going to find that one 0 0 0 1, right? So that one we will be marking as a 1 as well. So we'll be marking those two now. 1 and 1, right? So now we're going to be moving on to the rest. This is this square, right? This is another one and it will be 0 0 1 0. So I'm going to clearly show you guys how that is made. So 0 0 is this column, right? So that's the 0 0 column, and the other part was 1 0, right? So we're going to find 1 0 from this, and there we have it. That is the 1 0 row. So the place where they intersect is this square right here. So we're going to be marking a 1 over there. Just like that, what we're going to do for the next line is we're going to be looking for the square with 0 0 1 1, right? So over here we have 0 0, and when we are moving down through that line, right? 0011, this is the 1 line, and where they intersect we will be marking our other binary 1 digit, right? So there we have those few ones marked, and the rest I'm going to be marking with the digits, bigger the numeric digits, because it's a lot faster. So we have ones on 4, 5, 6, 7, 8, 10, right? 4, 5, 6, 7, 8, 10. 4, 5, 6, 7, 8, 10, right? So we'll go back and see what else we have. After 10 we have a 1 in 13 and 15, right? So we'll be marking 13 and 15, and the rest are zeros, so we'll be marking the zeros as well. So now we have completed marking all 4 of our K-maps, and I hope that you guys understood how to actually mark K-maps, right? These are the 4 K-maps that we marked, and these are the truth tables that are corresponding to those K-maps.